Now, when we do have independent events, our multiplication rule simplifies for those independent events. So if they're independent, probability of A and B, remember that's the same as intersection, is just probability of A times probability of B. So remember for conditional probabilities, this was probability of A times probability of B given A. So, but B given A is the same as probability of B. So that's where that's coming from. And then note that any probability rule you have has a version of that that includes conditional probabilities. So for example, the probability of A and B given C is the probability of A given C times the probability of B given C. So you just do all three events given C. So I did this one, and this one given. So as long as everything is given the same event, that's another version of that probability rule. So let's look at an example here. What's the probability of a couple having 5 boys in a row? Well, having a boy first, second, third, fourth, or fifth, those are all independent events. So we're trying to find the probability of a boy first and a boy second and a boy third and a boy fourth and a boy fifth. And since these are all independent, we can just multiply the probabilities. So this will be probability of a boy first times probability of a boy second, all the way up to probability of a boy fifth. And then each one of these is 1/2. So this is just 1/2 times 1/2 times 1/2 times 1/2 times 1/2, which is 1 out of 32. So if you have multiple consecutive events, if they're all independent, just multiply the probability of each separate event. So it simplifies our multiplication rule for independent events.